More often than not, the conceptual designs have been done by the consultants who work with the client, so they've already taken the client brief and come up with a design. So for us, it's about, before we start that design, understanding what the client wanted, what the aspirations were for the building, and then working with the wider design team, like the architect, structural engineers, and the client, to ensure that we take that design forward to completion. So it's more about collaboration between different parties. As I say, ensuring that we've understood that client brief, and we're kind of the last line of defence, where nobody else is going to work on this design before we start on site. So the sort of buck stops with us on that, where we need to get the design right for our site teams to make sure that it's a nice, smooth process for our install. I think one of the main benefits to BIM and 3D modelling is putting all the different design team members in the same space. Back in the day, when we used to use CAD and we didn't have this environment, we all kind of worked in isolation and then met up every couple of weeks to solve issues. But now you can have people working in different cities or even different countries who can all be working in the model live at the same time. So it allows us to work more closely together and solve issues more quickly. It also helps us understand what everyone else is doing and what the other disciplines are. So for example, if we've got an issue with fitting something in, or some plant items don't fit, we can easily visualize that with the rest of the design team so they can understand what the issues are. So I think these tools have massively helped with coordination, but I think the biggest benefit is putting us all together in one live space, which we just didn't have previously. For clients, it'll reduce their risk and it'll give them sight of what they're getting prior to us actually building it. For us as contractors, it helps us maintain program, because we can solve issues in the model virtually prior to us being out on site, where clashes and issues can affect program. They can be wasteful in terms of materials and things like that might need to come out and go back in. So solving those in a model helps kind of everyone involved, and it also ensures for the end user that we've been able to look at things like maintenance better, because we've been able to see it in a model beforehand. So it kind of helps everyone involved, client, us as a contractor, and the end users. So the software now, it's kind of got some semi-automation in those processes, so it can identify clashes for us. For us, which might have been more difficult to find previously, but it does still involve a lot of intervention from the people working within the software, and they need to understand what a clash is and what a clash isn't. So whilst it does semi-automate those processes, it still very much involves a lot of hard work from the teams, and that'll help us identify like clashes or space constraints or issues in plant spaces where we might not have enough space for access and things like that, which you wouldn't have seen previously without having these models. So they've been the Revit, BIM, Navisworks, these softwares have really helped speed up the processes, but it very much still does rely on somebody working in those spaces and understanding what they're looking at. Those three things: future ready, efficient, sustainable, they have to be thought of right from the start. So we can't be looking for a design and then adding these features in at a later date. So, and that will all be part of the client brief. So when you think about making the designs sustainable and efficient, I think it's about looking at material choices and where we're gonna get equipment from, where we're gonna get materials from to make it more sustainable to get them to site, because that'll affect how much carbon is released into the atmosphere while we're actually building the building. And then when you look at efficiency, it's all about making the building efficient from the start. So it's about reducing energy wastage rather than trying to make some new energy on site. So we can introduce things like photovoltaic panels or heat pumps. Obviously we've completely moved away from fossil fuels, using the right technologies from the start, but also reducing wastage in the first place. And then when you think about how these buildings will last into the future, because it's going to be there for a long time, we have to think about things like, you know, can the services be adapted so that building could be used for something else, or can that building cope if it was a really hot summer? Because, you know, through climate change we're seeing, you know, more extreme weather events. So it's how those buildings cope in those sorts of situations. So we do that by using a thermal model, and we can look at these different scenarios like future weather events in a thermal model and see how well the building reacts to those events. And then we can then look at whether things need to be tweaked a little bit in terms of size and plans, making it a little bit bigger. But you've got to be careful. You can't just make things bigger, because that makes them actually less efficient when you're not in an extreme weather event, and it also increases how much carbon it is put into the atmosphere from the actual build, because essentially you're putting more stuff into the building that you might not need. So we use thermal and energy modelling during the design process to actually, you know, iron out these sorts of things that we think might come in the future.